Welcome back. Seeing how you are becoming more comfortable working with requests and APIs, we will briefly go through the rest of the data provided by this exchange rates API. So far, we've been using only one endpoint of the API, /latest for the latest exchange rates. In addition to that, the documentation mentions a couple more endpoints about historical data, historical rates for a single day since 1999, and historical rates for a time period. We'll start by defining a new base URL, one without the slash, like that. To request exchange rates for a particular day in the past, we add /date to the URL, where date is in the format year, month, day. Let's set the date to the 26th of January 2016. Okay. Submitting a new request yields a valid response. We then store the JSON into a variable and print out the data with the dumps function. We have the expected result. All exchange rates from the 26th of January 2016 in the same dictionary format. Neat. However, we're rarely interested in a single date. More often, we prefer to have information about a certain time period. Well, this API provides that too. The URL for this request is formed with /history and parameters specifying the start and end date of the said period. The start date is represented with the parameter startAt, while the end date with endAt. So let's set startAt to 26th of April 2017. To combine the two parameters, we use an ampersand as we suggested before. Then let the end date be the 26th of April 2018. In order to reduce the clutter, I will also choose to obtain only the pound sterling rates. Once more, we add that parameter with an ampersand. Good. That's the final URL. Let's combine the request and extraction of the response data in a single step again and then display that data as usual. The result is 3 dictionaries nested into one another. The outermost dictionary is the usual one, containing the main parameters, such as base, startAt, endAt, and rates. Note that rates itself is another dictionary that contains every date as a key. Finally, the value of said dates is the last dictionary that includes all selected currencies and their rates. However, the dates appear to be randomly ordered. This is a peculiarity of this API and not our methodology. There's a simple fix for that. We can set sort keys to true in the dumps method. And now they appear chronologically as we'd expect them to. Fantastic. Up until now, we have seen how this API responds to queries to all of its endpoints. There's still one thing left to test out. What would happen if the request is invalid? Well, there's only one way to find out. I'll make up a date where the month is 13 to ensure the invalidity. The server responds with the status code of 400. A quick Google check informs us that this code stands for a client error of a bad request. In addition to the status code, many APIs also return a custom error message. We can find it contained in a JSON, where usually the information would be. It clearly states the date does not match the required format. What if the date is all right, but we input an incorrect code for the base currency, say USB instead of USD? Here's the response. The status code is the same, and the error message states that this particular base is not supported. Finally, if the value for the symbols parameter is mistaken, the error reads that the symbols are invalid for the particular date. It is generally important to be aware of the behavior of an API to different kinds of input. A good API would have documented all possible errors in a way that immediately makes clear what we've done wrong. All right, that's all that this API offers, not that it's little. Next time, we'll see how we can use its capabilities to create a simple application. Thanks for watching.